you got to firstly find what the force solution is, which to find that you'll draw it at t equals infinity. And then once you find out what that force solution is, then and only then do you find the total solution. And the total solution is the sum, is the sum of your natural solution plus your force solution. And that's when you're going to substitute in your initial conditions. Thumbs up on that. If you try to substitute in your initial conditions here, you'll get the wrong answer, because see why? If you substitute in t equals 0 here, if you substitute in t equals infinity here, what will be left? Nothing will be left at time equals infinity. But you know you should have something left at time equals infinity, and you're going to get into trouble. So let's figure it out. You're going to draw it for t equals infinity. What does the, I'll just draw it. I mean, you guys totally get this. 24 volt source. At time equals infinity, whatever was changing has stopped changing. This V natural solution's decayed away to 0. You're back in your DC steady state. So your inductor looks like a short and your capacitor looks like an open. And there's no reason to draw that one resistor that's hanging out on the right, because we're only interested in what VC is. And that's the other point that I want to just reinforce. Different than what you did in first order circuits, in which everything you firstly found either VC or isobel, and you only solved for whatever you were asking for at the very end. For second order circuits, the only time that you ignore what you're asked to find is in this first step of finding initial conditions, where no matter what you're asked to find, you find isobel and VC. Everything else, you're trying to find your XC. You want to find your X natural for your natural solution. You want to find your X forced for your forcing function. And you want to find your X total, which is equal to your natural plus your force solution for step 4, where X is whatever you're asked to find. Maybe it's current through an inductor or current through a resistor or voltage across a resistor. It just so happens that for this particular time, it happens to be one of our simple state variables, which is V sub C. So we're going to find V sub C directly just by looking it off. Aiden, can you tell me what VC is, what your force solution is?
It should be 24.
It's got to be, no matter what this resistance is. It happened to be 5, but your force solution is going to be 24 volts. And again, it's the voltage across the capacitor, because that's what we were asked to find. We weren't asked to find the current through the inductor.